So what would you do if you wake up tomorrow and you found that there is no internet today? Like you are disconnected from the world. So question raises here, can you imagine a day without an internet? So if you see, in today's world, network keeps us connected across nations, borders and continents. Now if there was no internet, what would you do tomorrow? So let's start from knowing some facts around here. So there is one very beautiful say, which is called "a cloud is under the ocean." So if you see, these are the images that are of the optical fibers that are laid under the ocean to provide the internet across the world. So actually, if you consider the possibility, this sentence, "the cloud is under the ocean," which is true. So these are the actual machines which are used to lay optical fiber cables under the ocean. And this is the actual size comparison. And these are the photos where human is actually maintaining or fixing the problems for the cable under the ocean. Now these are some of the images where you can see these are the traditional towers where using these towers, company or internet service providers provides us the internet. And these are the latest technologies. So this is like air fiber internet, where we receive the internet without having to lay you can say underground fiber optic cables around or near our homes. And these are some of the images or comparison for next generation of internet, or can you say that? So the basic idea of the Starlink over here is to provide an internet using the satellites, so low orbit satellites, and like thousands of satellites connected across you can say hovering around the globe, across the globe, to provide you the internet. And these are the kind of satellite antennas that will receive and signal, and this is kind of like an access point that will provide internet to your home. Now if you were to imagine a day without internet, how would you live without that? And if that is not the problem, let's just look at the global connectivity race. So you can see this is data from Ookla Internet Speed Test Company, where you can see this is latest data of 2026. You can see the countries listed over here and the maximum speed of internet that we can get in that country. And you can see the Middle East countries are on the top, while India is still ranked 37. So what happens if you lose the internet today? Why network is so important? Let's learn that with Networking Fundamentals series that we are going to start with Video Geeks. So welcome to the session 1, when we are going to just briefly give an overview of what is network. Just few traditional definitions. There are introduction to networking components, categories and characteristics. So let's look at that. So when you start a networking topic, people always start with the OSI layer, but we are going to actually start from the one step below or before actually getting to know what OSI model is. So there are some rituals like we have to follow. If you start some subject, you must understand some definitions and stuff, right? So what is network? So network is a group of components that connects together to provide the services. Now you must raise a question that what are those services that we are getting provided by? So those services examples are like this: access information, just like you're browsing information over the internet. Like if you scroll something on websites, right? Then file sharing, where you download and upload files on the internet, like YouTube videos. Resource sharing, like you upload some document on internet and share it with each other. VoIP, video chatting, and many more. So these are the examples of services that are provided over the network. Network categories. Let's actually, in order to understand the network, we must understand what are the categories, how it can be categorized, right? So a network can be categorized into three main factors. The first is its geographic scale, its structure, and its transmission mediums. So let's first understand what are the categories based on geographic scale. So something like PAN, personal area network. So these are arranged in order from small to big. So the PAN is very small network. Then a little bigger than that, which is called SOHO, small office, home office, then LAN, local area network, then MEN, metropolitan area network, and then WAN, which is called wide area network, or you can also call it this is an internet. Now, in order to actually give you an example, these are some of the images for the network categories based on its scale. So this is something called personal area network PAN, where you have a laptop and you have certain devices connected to it, like headphones with Bluetooth, then printer, then tablet, and some other stuff like that. Then this is something called your small office, home office, where you have an modem which is providing you with the internet, and then you have wireless access point, or which can also provide wireless and wired connectivity. Then this is something called LAN, where you have a large building and devices are connected together using some network devices, right? That we will see actually in upcoming slides. Then you have something called smaller LANs which are connected. So let's say you have one city, which is and in that city you have multiple such buildings, and all the buildings are connected together. So this will form something called MAN, where the networking is happening between multiple LANs in the same city. Now let's imagine that you have multiple cities together connected through some networking devices. So that you can consider as in WAN, where multiple MANs are connected together. So this is kind of like an idea for you to get network categories based on its scale. Now, before we talk about the other categories that we have seen before, we need to actually understand about networking components and topologies. So now let's understand those. So the first is network components. So what are the different network components that we can see? So there are three basically categories of network components, where the first is endpoint or end devices, where actually your network starts or ends. So something like PCs, laptops, mobiles, printers, those are something called endpoints. Then the second category is network devices, where this devices helps you routing of your traffic or bridging of your traffic, or you can say this device helps connect other devices together. So something called hub, bridge, switches, routers, firewalls. Those falls under the network devices. And the last is connectivity, which is also called as in transmission, something like wired, wireless, and optics. So these are different categories of network components, and these are some of the common images that are used over the internet. So laptop, printer, mobile, or PC. Then hub, switch, this is also a representation of a switch, router, wireless router, this is something called Ethernet cables, RJ45 connectors, fiber optic cable, and SFP connectors. Not worry about if you don't understand these few things which are mentioned over here, because we'll explore this in much details. Now let's talk about the topology or network representation. So a topology is a description of how devices are connected together. So basically there are two types of topologies or representations that we can have. So the one is physical and other is logical. And as the name suggests, physical topology is the representation of how the devices are connected physically together. And the logical is how the devices communicate internally, or how the internal circuit behaves. And based on that, we have certain categories. So those categories are like point-to-point, common bus, token ring, star, and mesh topologies. And all of those categories are given as an example over here. So a point-to-point topology is like where there are just two devices and they are connected together. This is something called common bus topology, where all the devices share one single common channel. You can see all the devices are connected together and they share this common link. Then you have something called ring topology, where the devices are connected in a ring fashion. You can see these devices are connected in such a way that they are forming a ring. Then this is something called a star topology, where you can see the devices are connected using some intermediate devices or central devices, you can say. So the backflow, or you can say con of this type of topology, is that this topology falls under the single point of failure. Well, let's say one device or central device fails, then all the devices that are connected through that central devices will lose the connectivity. Then the last thing is called mesh topology, where you can say the devices are connected in such a way that it introduces redundancy and there is no single point of failure. So let's say this link fails, still this PC and this PC can communicate through this path. So this is something called mesh topology. And based on that, we must understand about network characteristics. So this includes this certain rules or certain things that we must follow while forming a network. So those are something called, those are listed over here. So the first one is cost of installation, maintenance and setting up. It should be less. Then redundancy. It should be high, as we have seen in the mesh topology. Availability. It should be high, like network should be available. Speed, it should be more, because at the end of the day you won't feel good if you're feeling a lag while watching a video. Scalability, it should be scalable. Later on, if your device or office scales to 20, to add more 20 devices, or let's say 100 of the devices, then your network should support scalability of your office, right? So it should be scalable. Security, it should be secure. So let's say you have built an office, it should be secure enough to let's say your devices that are connected to your internet or connected to your office network, they should be secure enough so that nobody can intrude your office network. And based on all of the characteristics that we have seen today, very well known topology that exists in today's world, or you can say this is very good example of topology, which is called universal leaf spine. So this topology introduce or take account for all of these characteristics that we have seen, like the cost of installation is low, then redundancy is high, high availability, high speed, high scalability, and more secure. So this is something, an example of universal leaf spine. So these are the spine nodes, these are the leaf nodes, and they are connected in this fashion where all the spine nodes are connected to all the leaf nodes, and each two leaf nodes are connected together to introduce redundancy, and then later on the end devices are connected to the leaf nodes. So this is how your universal leaf spine topology works, and at the end spine nodes are connected to internet, and your all the traffic from the network will go via spine you can say nodes to the internet. That's it for the first session. I hope you have got the idea about what network is, and basically that's the introduction of what network is. We'll explore more introduction of more what you can say interesting parts in next session.
Question, a quiz in the description. Go check it out and answer in the comments. Thanks.
Yep. So